Hello everyone. In this video we're going to be talking about linear functions applications. So we've learned all about linear functions throughout this unit. Now we're going to look at some applications that we have with it. And so first let's recall my slope that is equal to m, which is equal to my change in y over my change in x, which is really the same thing as rise over run. And so let's go ahead and look at this first example, and we're really going to see several different ways that we can represent linear functions, and we're also going to be interpreting the slope and y-intercept of it. And so for this first one, it says that Erin has a jar of 16 Skittles. Every minute she takes out 2 Skittles. And so I first want to identify my independent variable and my dependent variable. And remember, the independent variable, that's always your x, and your dependent is your y. So my independent variable is the one that's changing. It's what you're inputting into the function. And so here, Erin having a jar of 16 Skittles, every minute she's taking out 2 Skittles. What's changing every time is the number of minutes that has passed. So my independent variable is number of minutes, which is minutes. While the dependent variable is what's affected by the number of minutes. And what's affected by the number of minutes is the amount of Skittles. So it's going to be number of Skittles. Because depending on how many minutes have passed, that's going to determine the amount of Skittles that are left in Erin's jar. And so next I want to write a linear function to represent this situation. And so I first want to identify what the starting value is. And remember, that's always the y-intercept. Your starting value is the y-intercept. Well, how many Skittles does Erin start with? She starts with 16. Now the slope, it's what's happening to the equation, what's making it change. And the slope here is the fact that she's taking out 2 Skittles every minute. And since she's taking it out, it's going to be -2 because she's taking 2 Skittles every time. And so that means that this linear function is going to be f of x is equal to my slope -2x plus 16. Okay, now for this third one, we're going to go ahead and fill in the table of values. So I want to fill it in for all the minutes that have passed. And so here I know this is really just -2x plus 16. So to find this first one, I'm inputting 0 in for x, so I want to find f of 0. So that means I want to plug in 0 here. So -2 times 0 is 0, 0 plus 16, I get 16. Now for 1, I want to plug in 1. -2 times 1 is -2. -2 plus 16 is 14. Now I'll plug in 2. -2 times 2 is -4. -4 plus 16, I get 12. Now I'm going to keep on going. So -2 times 3, I get -6. -6 plus 16, I get 10. And so you may notice all I'm doing is I'm subtracting 2 every time. So I'm going to go ahead and fill in the rest, just subtracting 2. And that's because -2 is my slope. And so I get the rest of that table. And now I'm going to go ahead and actually graph this function. And so it says to label the axis and graph. So I'm going to label this as number of Skittles, or Skittles in jar. My independent variable x, we saw that was the number of minutes. And the independent variable, or the dependent variable, was Skittles. And I'm going to go ahead and actually graph this, and I can just use the points from this table, because really this 0, 16 is the same thing as the point 0, 16. However, you'll notice I do not have 16 lines right here. So I need to actually change what each of these lines indicate. And I'm going to change that to 2. I'm going to go by 2. So I have 2, 4, 6, 8, 10, 12, 14, 16. That's because my y here, it goes up to 16. Here I'm just going up by 1 each time, so I'm going to leave my x-axis to go by 1s. So now I can go ahead and graph 0, 16. And then I have 1, 14, 2, 12. And so I see it's just going in this straight line. Okay, now let's interpret what some of these mean. So the first question asks, what does the y-intercept represent in this situation? So the y-intercept here is 0, 16. And this is my x, this is my y. Well, we know that x is number of minutes, and the y is Skittles. So number of minutes passed is 0 minutes. So that means that at 0 minutes, Aaron had 16 Skittles. In other words, Aaron started with 16 Skittles. Okay, now let's see what the slope represents. So my slope is -2, and I can write that as -2 over 1. And I know it's my change in y over my change in x. Well, my y represents number of Skittles, and my x is minutes. So to write what that represents, that just means that Aaron takes out 2 Skittles every minute. So Aaron takes out 2 Skittles every minute. So I have my y value first, and my x is over that. So 2 Skittles for every minute. And now this last one asks, what does the x-intercept represent in this situation? So my x-intercept I can find right here. So that's at 8, 0. So my x, again, that represents minutes. My y is the number of Skittles. So after 8 minutes, there are 0 Skittles in the jar. So I can say after 8 minutes, there are no more Skittles.